So, which of the following statements is incorrect about hemoglobin? First of all, hemoglobin demonstrates higher oxygen carrying capacity compared to myoglobin. There is a covalent bonding between the four subunits of hemoglobin. During oxygenation, the loss of first oxygen molecule from the oxygenated Hb promotes the dissociation of oxygen from the other subunits. So, to answer this question, uh, we'll go back to this graph. So, you can see here that is hemoglobin, myoglobin, and this is the case where there is no cooperativity. So the first answer says that hemoglobin demonstrates higher oxygen carrying capacity compared to myoglobin. So in this graph, it shows here, see, 7%. So only 7% of the oxygen which is carried by myoglobin can be given or can be released from myoglobin so that the tissues can take. That is that why it happens, because myoglobin binds to oxygen more tightly than hemoglobin. But in hemoglobin, you can see that there is a 66%. 66% there is a chance. So 66% of the oxygen which is carried by hemoglobin, it is released when once hemoglobin or that RBC reaches the tissues. So at that point of time, so it is considered that hemoglobin has a higher oxygen carrying capacity than myoglobin. So this option is correct. Okay. So we have to choose the incorrect options, but this option is correct. So 2, there is covalent binding between the four subunits of Hb. So this option is wrong. There is no covalent binding between the four subunits of Hb. They are just bound together by hydrophobic interactions and all those things. There is no actual covalent bonding. Okay. So this option is incorrect. Number 2 is incorrect. And then we have, during deoxygenation, the loss of the first oxygen molecule from oxygenated Hb promotes the dissociation of oxygen from the other subunits. So, how is this explained? During deoxygenation, the loss of first oxygen from the oxygenated Hb promotes the dissociation of oxygen from the other subunits. So, this is why, because the hemoglobin displays cooperativity. So there are two models, the concerted model and where you have the tense state and the relaxed state, and it says that binding of oxygen at one, or binding or dissociation of oxygen at one of the like hemoglobin molecules, so it will lead to dissociation or bind, like if it is binding, then it will lead to binding of the other binding of oxygen from by the other hemoglobin molecules and vice versa. So this is because there is cooperativity. So therefore this option is only also correct. So the only option which is wrong is option number 2, and here it is denoted by A. So only incorrect option is A. That is number 2. There is no covalent bonding between the four subunits of hemoglobin.